Good afternoon. Welcome to the NMRA Electrical Clinic that was done at the Dranesville Community Center today, and we'll move forward. It's an introduction. The Model Railroad electrical AP certificate requirements can be done on one or more private or club layouts. To qualify for the Model Railroad Engineer electrical certificate, you must complete several requirements that appear to look long and complicated, but when you look at them, you will realize that you have several options for meeting them, and this is what makes it appear to be a hurdle. Something you want to remember: don't make the requirements more complicated by reading into them and making it more difficult for you to achieve this. Requirement number 1. Construct and demonstrate on your own or a club layout the satisfactory operation of an electrical control system on a model railroad capable of simultaneous and independent control of two mainline trains in both directions, containing at least 1. For conventional DC wiring, non-command control, 5 electrical blocks that can be controlled independently. For command control wiring, this would be DCC, TMCC, LCC, and others, sufficient gaps and switches to maintain polarity, phase if needed, and troubleshooting. So the simultaneous and sequential and independent control of two trains. Well, as a tip, this can be as simple as a single track main with sidings. If you can cut the power to the sidings individually, you can run one train, park it on the siding, while you run another, then park it and run the first again. So that's as simple as we can make this, not complicated. Additional requirements are: 1, you need to have a mainline passing siding, and this siding is there to allow you to have trains pass each other, and there needs to be a reversing loop Y turntable or a transfer table that allows you to turn a train around. Now, the requirement isn't to turn the entire train, but the objective is to turn the locomotive around or to put the locomotive on the opposite end. Thus, the ability to be able to do a runaround could meet this requirement. Additional requirements: 1 yard with a minimum of 3 tracks and a switching lead independent of the main line. And this means independent means that you can operate a switching locomotive in the yard without interfering with the mainline operations. So that switching can take place and the working within that yard can be done, but in the main line can continue to function like nothing was happening. It's a totally separate operation. There's a requirement for facilities for the storing of at least 2 unused motive power units. The tip here is you need a track, perhaps a spur, to store unused motive power units, and if using DC, be able to cut the power to the track off. You can do the same thing with DCC also. Thus, if you have a siding or a spur or a yard that you can put the unused motor units into, like at an engine shop as an example, you can park the engines, be able to shut the power off to them so it's not demanding power when we're not using them, and not affect any operations on the main. Additional requirements: 1 power supply with the protected devices, being a short indicator or circuit breaker to ensure safe operation. Now, this isn't a GCFI kind of thing. You plug it on an outlet. No, this is dealing with the power on the layout itself, the layout power. Thus, something like a circuit breaker or, as an example, dealing with the PSXX AR, it has a circuit breaker with it also, could do this. And we know that our power supplies typically have a device, a circuit breaker that's going to kick out if we're drawing more. On my layout, for an example, my power supply is capable of 8 amps. If I draw to more than 8 amps, it trips the circuit breaker. So that's not a good thing, and we're trying to protect our locomotives from not having issues with short circuits and such and affecting the decoders and having decoders go up in smoke and such. So the tip here is this does not have to be built. All is required that you have on your control system, and it could be a commercial power supply with the required features. Wire and demonstrate at least 3 of the following items. Now, we talk about turnouts, crossovers, slip switch, single or double, double junction turnout, gauntlet turnout, operating switch and overhead wire, a crossing, a double crossover, a gauge separation turnout, a 3-way turnout, a spring switch, or other. So we're trying to demonstrate at least 3 of the following. Now, some interpretations are saying that we could have 3 turnouts. Another interpretation is that you have to have a turnout, perhaps a crossing, and perhaps a gauntlet turnout as an example. So we need to clarify that with our AP manager to see exactly what needs to be done. A couple of tips for the turnout: hook up power to a powered turnout. That's one way to do it. And for the crossing, most commercial crossings come pre-wired, so you just have to set one up, and so you can run trains through it with both tracks. A critical thing running trains through these devices. For example, on a crossing, it's a good idea to use a longer wheelbase locomotive than a short wheelbase, so that if you have an issue with power, like in the exact center area of a crossing where we can't have power, because if we do with DC or DCC, we're going to cross something up and cause either the phases to cross or have a positive and negative thing that cause a short, and it's not going to work. So some tips also here is you don't have to scratch build anything. All you have to do is show that they work electrically. And of course, if you really want to scratch build something, go for it and make it more complicated. I do believe that the KISS principle, keeping it simple, stupid, for Ernie, is something we need to do. And like we said before, don't make the requirements of 1 and 2 any harder than they have to be. Requirement number 3, wire and demonstrate the electrical operation of at least 3 of the following items. We talk about electrical turnout position indication on a control panel or at a track side for the minimum of 4 turnouts. So as an example, we could set up an LED that would indicate whether the switch is normal or thrown. So that'd be one way to do it. And there's also the ability to have track occupancy indication on a control panel or at track side for a minimum of 5 blocks. So those are the requirements there. Additional requirements: cab control, making provision for the connection of at least 2 power supplies to a minimum of 5 blocks as trains progress. And the tip here is you need at least 5 power blocks on the layout, each of which can be controlled by 1 or 2 power supplies. The 5 blocks do not have to be in a row along the same stretch of track. Additional requirements: an engine terminal, including the electrically powered turntable or transfer table with a minimum of 3 stall tracks and at least 2 block storage sections for parking of locomotives outside the stall area. Very similar to what we were talking about before in the other requirement. The bottom line here is you need to have a total of 5 tracks, 3 inside the engine house or roundhouse and 2 outside, that you can store motive power on, and if necessary for DC, cut the power off to the storage tracks independently to store the motive power. But we can do the same thing with DCC. The ability to shut the power off is a good thing, and it conserves power on the main power supply. 2 turnout junctions with electrical interlocking and protecting trackside signals. This is a turnout with an electrical protection to prevent a train from going through a turnout that is set against it. And obviously, if we go through something that's set against us, we're going to have a derailment. Electrical terminals on a switch machine combined with a couple of insulated roll joiners can make this easy. So we have a switch machine, we have tortoise motors, we have MP10s, other types of turnout motors that are available to us that we could use. and we can set it up such that the terminals do give us indication as to how the switch is thrown. The turnout is thrown. I'll say it that way better. Additional requirements, high frequency lighting, which is the same thing as constant lighting. An electronic throttle with inertia and braking provisions. And this can be combined with requirement 1F as mentioned before. A grade crossing with electrically activated warning indication. Now there's several different types out there. You have some that use an infrared device that senses the train coming and the train going. So it turns the lights on and off, basically a ding, ding, ding the bell and make the lights flash. There's other things that require pressure, perhaps, in some of the older stuff, and maybe in the Lionel series, if you will. But there's different ways to do this. So we just want something that has a grade crossing with electrically actuated warning indication. Like it says, the tip is there's several commercial components available that you can just wire up and meet this requirement. You don't have to design or build the circuitry, bottom line. And if you want, you could use commercial plans that appear in magazines from time to time to build one if you can do it from scratch, if you really want to and complicate your life. Additional requirements, two-way block signaling with automatic train detection for at least 5 blocks. Okay, so we want to make sure that we can signal in both directions so the trains can go either direction. Now, obviously, signals only affect one direction of the train. That's the reason why when we draw them, we have the little line with the lights at the far end so that we can tell which way that signal is being indicated and which train it's connected to or which train it's controlling. And once again, there's several commercial components available that you can just wire up and meet this requirement. You don't have to build or design the circuitry. And if you want, you could use commercial plans that appear in magazines from time to time and build it from scratch if you really want to. Once again, that can make your life complicated. Operating overhead wire, catenary, either using pantographs, trolley poles, or both for current collection. Installation of advanced electronic or computer control for a model railroad. Well, we have DCC out there today. We have command stations. That's an example of what we're talking about here, computer control of the railroad. Design, installation, and operation of animated mechanical or electrical displays. There's a ton of things out there that you can get that will animate, whether it be like a marquee on a theater, a marquee or another circuit perhaps that flashes a light or lights on a antenna, that sort of thing. It doesn't have to be a huge animated display. Think about animated industries or signs to meet the requirement. Design, installation, operation of mechanical or electrical layout lighting displays. Well, this is dealing with the illumination of the layout. It's not dealing with buildings. And, the layout lighting is important because you want to be able to see your layout or take pictures of it. And it would be nice to be able to show daylight versus sunrise, sunset, and the like. So you could take something like, if you go to a Home Depot or Lowe's and buy one of those little LED packages that you can install on a deck where it has a transformer with it and a remote control so that you can change the color of the lights and dim the lights, make them bright, so you can do daylight, night, that sort of thing. I think of Tom Picarello's layout up in New York. I've operated on it, and he has a scene he does at night where he turns all the lights out and all you see are the stars, and you're trying to turn your train, so you pull in your flashlight out, and he can tell you, put the flashlight away, we got to be able to see the stars. So all we're trying to do is eliminate the layout and show a difference of daytime, nighttime operations. Installation of a command control receiver. Okay, well, decoders in locomotives for DCC certainly would meet that requirement. And modifications or additions to the device's wiring are required. Installing a plug equipped decoder in a manufactured pre-wire socket does not meet the requirement. But if you take maybe a DC locomotive and convert it to DCC, and you have to take the wiring and isolate the motor and such, that's what we're talking about here. Installation of a command control throttle bus line around the layout capable of handling at least 2 throttles at 3 or more separate locations. So we might have a local net similar to a Ethernet or other type of communication line. That's the bus line we're talking about. Be able to hook our throttles in so we can have tethered operation, or be able to require a locomotive. There are some commercially assembled complete units that are not acceptable for the requirements. Well, construction installation of a sound system. Well, I can remember that recently I was going through the stuff that I have in my layout, and I found an old MRC sound system that had 2 speakers and a little remote control that you could blow the horn, long and short. You could make sounds of cows. You can make a coupling noise and uncoupling noise and such. And certainly that's something that's there, but that's something that you're just, plugging into the wall and it works. Well, that's not what they're looking for. They're looking for some other thing, certainly with the various small computers, the Arduinos, the Raspberry Pis and such. There's things that you could do. So it doesn't say it has to be an onboard system, but it could be underneath the layout. So I can think of Steve Gittleman up in Long Island, and he has on his layout several locations where when you approach that location, like a farm, you'll start to hear cows moo, or you might hear birds chirping, or perhaps another part where he has a forest, you might hear a bear growling, or that sort of thing. The last thing here is construction and installation of a signaling system. So if you're going to have signals, you can put the signal system out there to indicate how your trains are supposed to be going or stopping and such. And a lot of this becomes electronic interconnection with other devices. Development and installation of a CTC system. Well, just taking one out of the box and putting it up doesn't mean that doesn't work. However, if you were to build one that would have your turnout control, your signal control, then your actuator, if you will, that could be an example of one. Installation and operation of an onboard video system with GoPro cameras that are out there. You can put them on a locomotive and be able to record videos. When COVID hit, Bob Rodriguez, for an example, installed small cameras on flat cars and put them out in front of the locomotive so that people from outside the area, outside of his house, could operate trains. And that led to the ability to go anywhere in the world and tie into his layout, as an example, and be able to see where the train was going and operate the train, because he created that ability through his control system. Computer generated block detection information. Well, we can set up signals, and we can say that it's occupied, not occupied, or we can make the signals turn red or turn yellow, or flashing yellow, flashing red, whatever the aspect you want to see, but we can do that via computer. Hardwired or stored control programs for the operation of the railroad. You just don't buy something and put it on the railroad. What you're looking here is buying a program, then setting it up for your layout to control your layout. Development and demonstration of computer to railroad interfaces. Our circuits has the ability through USB ports and such to link your computer into your command station so that you can talk to it, see what's going on in your layout through the LocoNet, and it also gives us the ability to be able to program locomotives and just see what's going on with our railroad itself. So that computer to railroad interface. And other. That's a ton of things. Examples of others include flashing warning lights on locomotives or end of train devices or on cabooses, etc. Some other things would be the use of advanced power supply, train control, track wiring, and track control methods, not to be restricted by the definitions and these minimum requirements that the NMRA is putting out there. Note that the operating third rail, center or outside on an overhead wired powered layout, may be considered for all aspects of the AP. The last thing is preparing a schematic drawing of the propulsion circuitry of the model railroad in section 1, showing the gaps, blocks, feeders, speed, direction control, electrical switches, and power supplies. One of the first things is propulsion circuitry. Well, usually we have something plugged into a wall, the cord, that goes to a transformer. The transformer changes the voltage and goes to a command station or goes to a control device in DC operation that allows you to change the presence of voltage on DC being on the track, or with the DCC, we're putting a voltage on the track, and then we have a decoder that says, hey, decoder, train number 1, I want you to speed up, and we can have a throttle to control that. So all we're going to do is show a diagram, and it don't have to be done with CAD. You can use Microsoft Office and all the various shapes to make squares and triangles and things to show what you're trying to show to meet this requirement. The propulsion circuitry requirement includes only the propulsion circuitry, so it's recommended that you make a separate diagram for that and not try to put into the other ones. If you want to put it all in one diagram, then it's suggested perhaps that you might want to make several copies and highlight what you're talking about if you're talking about propulsion circuitry, or if you're talking about electrical turnout control or the signaling systems, building lighting, and the like. All we're trying to do here is show how the electrical system for the layout is set up, and there could be multiple diagrams depending on how much electrical type things you have. And you don't need to include the details for parts of the diagram which are repeated. If a number of parts are wired in the same way, it's sufficient to draw one section in detail and indicate other locations with rectangles. As an example, if I was going to wire up a DP-DT switch to a turnout control, so that when I throw the switch one direction, the turnout motor moves the track one way, or if I hit it the other way, it diverts. We don't need to show every DP-DT switch and how we wired it. We can show one and say the others are wired like this. If we have multiple turnouts wired the same way, we can show the one turnout and say this is typical for my layout. Preparing schematic drawings, identifying the wiring and components in the 6 items in sections 2 and 3. And these schematics should be separate, as we said before, from the propulsion circuitry schematic to make it easy. If you're ready to have one overall schematic of the layout, like I said before, you might want to consider making multiple copies and going over the applicable lines with a highlighter for each feature so that the evaluators can see exactly what you're talking about. A statement of qualification, which includes the following: the track plan for the layout used in section 1, description of the track work features, method of construction, wiring, and identification of the commercial components used in sections 2 and 3, the schematic drawings required in section 4, and in a signed witness certification form, showing all the above items are operational and meet all the applicable NMRA standards. The form itself can be downloaded from the NMRA website. They are PDF fillable, so you can download them, fill them out to the computer, and send back. And those blocks that are shown in color here do expand and contract. And all we're doing here is checking the box. And when you're looking at trying to qualify for the certificate, these check boxes can help you say, I did it or didn't do it. And if you got them, you check them. If you don't check them, you don't have it, you don't check them. So we can see about if DC power, it talks about the 5 blocks can be controlled independently. If you can do that, check it. If it's DCC or TMC, something like gap switches for phase, for troubleshooting, you check it. If you got a reverse loop, a wire, or a turntable, you check it. If you got a passing siding, you would check it. If you don't check it, you don't have it. And the evaluators are going to be checking that when they come out to visit you. Wire and demonstrate the electrical operation of at least 3 of the following track items. We talked about all these items on this SOQ earlier. Now we're doing is checking off the box of the things we've got. Wire and demonstrate the satisfactory electrical operation of at least 3 of following features. And you can see all those things there. Once again, if you got them, you check them. If you don't, you don't. Then it talks about preparing the schematic drawing of the propulsion circuitry. We talked about that earlier. Then in the backside, this is what we'd use for the evaluators to be able to check off we saw the stuff and be able to sign off. So there is no requirement for merit evaluation in this certificate. To make it clear, you do not have to worry about getting 87.5 points. If you check the boxes, you've done the things that are required, and you can get the presence and operation of the required features being verified by a witness, that being the RP, region IP manager, or their designee. There's no problem, but there is not a minimum score. The bottom line is, did you do it or didn't you do it? Okay, after we finished the PowerPoint, we talked a bit about my achievement program submission for electrical that I did as part of my MMR process several years ago. So the first page, I'll go back here for a second, talks about who I am, the submittal, my NMRA number, and when I did it. Then the next page is going to go down. It's going to have a table of contents on several things here. Let me see if I can reduce this just a little bit so we can see it better. Yeah, I think you'll still be able to read it. But you can see the introduction and the parts. Now, it took me 29 pages, but you know, I could have done a lot less documentation, but I explained things, and I'm a technical type of person, and having worked in the fire service, I wrote a lot of reports that were very technical, and that created a situation where I wanted to explain things probably a little more in depth than I had to do. So as an example, we start here with it's a freelance model railroad that I constructed, and I did a stick diagram showing my layout at the time. Then I showed my propulsion, the way that power gets to the track. So I start out with a 110 volt source. We go to a transformer here that reduces things down to 18 volts, then an 8 amp circuit breaker. Then it goes from there over to the command station, which was a DCS 100. And then it went to a ramp meter made by Tony's Train Exchange. And that's not a requirement, but that's something I've got. And I wanted to know if I had track power on or not. And one of the things you got to realize is the fact that with DCC, as an example, you can have power out there. You got a sound locomotive, hearing sound, the lights are working, but they won't move. That's because your track power isn't completely turned on to get that local net, so it's sending commands back and forth. So talked about how you turn things on. I talked about the power gaps, where my power gaps were located. On my diagram, I've indicated my power gaps by these little blue triangles here. So that's where the power gaps were on when I did this back then, and since then I've gone to all my layouts expanded. That's all I can say. Local net connection points here, you can see that there's 4, and they're shown, so that's where my control points are at. And then I described how my system works, and I showed that I had a passing siding. It indicated there was a power gap on the passing siding as such on my layout. And I also explained how my engine and locomotive facility was there, and the power gaps it had, so that I could shut the power off to the locomotive, so I could store my power back up in here. If you remember, there was a requirement for that. Okay, then I've got a situation where I've got a 12 volt circuit. I've got a Radio Shack wall mark there that changes from 110 volts to 12 volts, and it goes through a turnout bus that runs through the layout. And it says 14 volt, but it was 12 volt. And that goes to my turnout control switches. Typically, it goes to a DP-DT switch, which I indicate here in figure 8 that I've got a wiring diagram for that. And that's that typical thing. You don't have to do every one. And it controls a tortoise motor through pin 1 and pin 8. So that's the first motor of several on the turnout control. And here's a blow up showing pin 1 and pin 8 once again. And here's the SPSDT, or sorry, the DPDT switch. And it shows how they're connected. We know this is the common, and we're switching between these. The power comes into one side, and we're switching what's going to these two to control that tortoise motor, which way it's going to go. Do the same kind of thing for an MP10 or the other various turnout motor control switch machines that are out there. Now I've got some crossovers, and I indicate here that there's two tortoise motors. In this case, they're hooked together. So if I throw one switch, I can make both the motors work at the same time to make it a crossover if you want. And it's showing how it's wired up from the diagram above, and then show it on the actual layout. And where I had to isolate the frogs and like on the switches and the rails and the built-in jumpers. I want to show that as the electrical, so I've got things set up. Hooking up an LED. The LED is there, and we took the tortoise motor, so we show we can hook up an LED to indicate the status of our turnout. In this case, we can use either if we put them in series, then we could use a multicolor LED versus red and green. If I'm using an MP10 turnout motor, it will not allow you to use a bipolar LED. It has to be red and green LEDs. And we're switching to grounds in that case. And it's showing the propulsion circuitry and the control points and the blocks and the feeders and all that kind of good stuff. We talked about that earlier. And we got the ramp meter and how those things are set up and how everything is working through my system, through the LocoNet. How the power going at the Littleton yard, it has controls each track. So each track going down the ladder has a status light, and it has a situation where it shows I can turn the power off to a particular track. This is showing once again in that same yard the way that the have a little panel here, and there's 4 switches, and I have the lights that go along with it. This is showing the power gaps once again. All I'm doing is working through the requirements and answering questions as I go through. Because remember, there is no score that's going to go toward you getting a merit. There is no merit award in this category. So we're just checking things off the box. Trying to explain. You have to list those commercial components you used on the layouts. What that is all about. Then we have installation of a command control receiver and how to, install a decoder in a locomotive and the wires and such, and the things we did. So it talks about general notes. Locomotive was tested and found to be isolated from the chassis, which if you're going to do DCC, it has to be that way. A stall test was performed to find out how much power was required. This required a 0.5 amp for it to stall, and all the connections were soldered. So I've installed a decoder in an old, what was a DC engine. So I had made some modifications to make it DCC compatible. And the thing to talk about there is the fact, if you just have a locomotive that's pre-wired, if you will, just to plug a decoder in, that's not going to get you to meet the requirement. They're looking for you to be able to put the wires in place and wire it up, just not plug it in. Plug and play is not going to work here. So that's talking about how I did it. This is an old, I started out as an undecorated Bachmann -8, and I just went through it and put the decoder in and such. So I described how I did that. Then the command and control receiver. And that's, once again, dealing with the decoders and where they went. So that's just a brief description of what my submission was and how it worked. And with that, that's going to be the end of the presentation. And I thank you for attending. Have a great day.